Hello everybody, this is Mr. Kusaj again, and this is part 2 of chapter 3-2, part 2. So now we want to look at, we talked about logs. What does the graph of logs look like? We know what the graphs of exponential functions look like, right? They go up quickly. What about logs? Well, let's compare. If you remember, the exponential goes through 1, right? And it approaches 0 here. And then it just shoots up. The logarithmic, remember it's inverse. So it goes through 1, but not this one, this one. It approaches the axes, but not this axis, this axis. Right? So this is the graph of a log, right? This is graph of an exponential. So identify them. This is exponential, this is log. So for example, if I was to graph 3 to the x, which we did in 3-1, right? So 3 to the 0, right, would be 1, and then 3 to the 1 would be 3, so I know it shoots like that. It shoots up like that and comes down to here, right? I can actually graph this without even doing the points because I know it's a mirror image with this line here. This one becomes this one, this asymptote becomes this asymptote, it shoots up that way, it shoots up that way, okay? So you can do just what we did before. You can do x equals 1, x equals 2, x, and then use a calculator slowly. But we'll talk about that later. Right now, what you're supposed to notice is that it goes through this one, x equals 1, and then this is, right, this is the asymptote. Also, this is interesting, it goes up forever. It really does. This is not a good drawing. This is a better drawing. It goes up forever, just like this, right? The difference is this shoots up like a rocket, like 1,000,000 miles a second, right? This one goes up slowly, like, a mile for every day or something, a mile per day. So it goes up slowly. But make no mistake about it. This goes up to infinity, right? Up infinitely, up infinitely. It's just that this goes up slower. But they both go up infinitely. Okay, that's an important fact. Okay, so some properties. If this number is bigger than 1, which is, that's all we're seeing so far, this base is bigger than 1, then it's going to do this. It's going to go through 1, but it's going to do this. But if this number is less than 1, like half or 0.5 or 0.2 or 0.1 or 0.7, less than 1, then it's going to flip over like this. It's still going to go through 1 here, but it's going to flip over like this. Okay? Those are the properties of the graph. Okay, so just like I said before, if you need to graph it, use a calculator and just plug in. By the way, you don't plug in -1 this time, right? Because if you look at the properties, we don't need -1. It never goes to -1, so we don't need -1. So what you should do is do 0, 1, 2. With the exponential, we did do -1, right? Remember that? But here you don't. So, for example, how would you graph log of x plus 4? Right? So, you know that log, the mama graph, the parent graph, goes like this, right? This is log, just plain old log x, right? It goes through 1, approaches this line here, and shoots up there slowly. Well, plus 4 means 4 to the left. You remember your transformation? If it's plus 4 inside the parentheses, then it's 4 to the left. So you take this and just redraw it 4 to the left. slide 4 to the left. Okay? How about this one? Well, you take a plain log x minus 5, that's outside the parentheses, minus 5, so that's 5 down, and then the minus is going to flip it over, right? So slide 5 down and flip it. So here's the regular, just plain log x, and then if I take that 5 down, here's the regular, just plain log x. If I take that 5 down, I'm way down here, right? 1, 2, 3, 4, 5. I'm way down here. Now I need to flip it because it had negative in the front. So I'm going to flip it. Okay? So I just graphed it. You always start with the parent graph, which is this. This is the parent graph of log. And then you do what you've done before, right? The negative here flips it. The number inside the parentheses left, right. The number on the outside is up, down. So you do what you've done before. Okay? For some reason, I don't have a try problem here. But I'll think of a try problem for when I see you next time in class. Okay, this was under 7 minutes. That's pretty good. All right, see you in class. Bye.